So for our next part of our discussion about dimensional analysis, I want to talk about how we actually use these conversion factors in order to solve problems. So let's look at our examples down here. The first example is how many feet are in 1.29 miles. Now, the way I'm going to do these problems, I'm very, some people call me psycho about how I want you to solve these problems and what I want you to show. So if I put something up here that is green, then you don't have to put this on your paper. But if it's red or blue, it has to be on your paper or it will cost points. I don't care if it's a cancellation mark, if it's a parentheses. If I've got it up here, it has to be on your paper. So the very first thing I always ask everyone to do when they're solving dimensional analysis problems like this, is to always find what it's asking you to find and circle it. So if it's asking us how many feet are in 1.29 miles, it's asking us to find feet. So we're going to circle that. Notice it's in blue. If you don't circle feet, you're going to lose a point. The 1.29 miles, then, I always ask you to underline any other piece of information that it gives you. So it gives you 1.29 miles. Notice also that that is underlined in blue, so that has to be there. So once I do that, I know that I'm going to be dealing with a problem that it needs a conversion between feet and miles. So the first thing that I need is a conversion factor, an equivalent statement for feet and miles. You may need to look this up or you may have it in your head, but the relationship between feet and miles is that for every 1 mile, we have 5,280 feet. So that's our equivalent statement. Notice something about that statement. It's in green. So do you have to show the equivalent statement on your paper? No, you don't. But the next part you do, because right beside the problem in brackets, please don't write parentheses. Please don't circle it. It better look exactly like I have it or you're going to lose point after point after point on this. I want it in brackets so it doesn't get mixed up with the rest of the problem. I want you to put your two conversion factors just like we did before. The fact that for every 1 mile, there's 5,280 feet. And I'll use FT for the abbreviation since I started it that way. Both F and FT are acceptable. But 5,280 feet or 1 mile. So I can use either one of these. So now I have my conversion factor. And I'm going to start the problem. And the rule for starting a problem is always start with a value that's given, always start with what you know. And the only thing that's given to us in the problem, and it's underlined, and it's going to be underlined so that it's going to help us remember how we need this set up in the problem. That's my starting point. Whatever I have underlined, that's what I want to start my problem with. Now, if you abbreviated that MI for miles, that's fine. It's an accepted abbreviation. Just make sure you use an accepted abbreviation. Notice I've underlined it. I've put it over 1. This is going to denote position for us when we do our problems. It's going to help us to realize after we write this up here what we need to do as far as multiplication or division. Now, I want this in parentheses. So whatever you start with, whatever's underlined in the problem, you're going to put that underlined over 1 in parentheses to start your actual calculation. Now, in the next part of the problem, we need to choose the conversion factor. And I often call this the conversion skeleton because I'm just going to make parentheses here with a line in between. And I may not know anything about what I want next in my conversion factor, but I do know one thing. When I multiply items together, if something is on an opposite side of a division line, I can, math teachers like to call it reduce it to 1. I often call it cancel it, but it's something like this. Let's say that you have 3 over 6 times 2 over 3. If you've ever worked a problem like this, you know that these 3's, anything over itself, reduces to 1, or cancels as I sometimes call it. So your answer is 2 over 6. They don't disappear necessarily, but they reduce to 1, and anything times 1 is itself. So this is the same thing we're going to do with our units. Anything we can do with numbers, we can do with units. So in order to get my miles to cancel or reduce to 1, I need to have miles right here in my conversion factor. What that's going to allow me to do is to reduce this to 1. So if I need to use have miles in that position on the bottom, then it looks like the conversion factor that I need to use is this one right here that has miles on the bottom. Now notice something. I've got some green stuff up there that does not have to be on your paper, but anything that's blue or red, including that circle I just made, must be on your paper. You've just lost points. So make sure that you do everything I'm asking you to do. Showing where I canceled or reduced miles to 1 also must be on your paper. So I'm going to put that conversion factor in here. The 1 goes with miles. The 5,280 feet will go then on top. And now what I want to do is to circle the unit I'm left with. So I'm going to circle that feet, and notice something. If we've done this problem correctly, then whatever we circled in the actual word problem must match whatever we circled in the calculation. So that's a quick check. And whatever we circled must be on top in order for that problem to end up solved correctly. So this is a correctly solved problem. Now, what this tells us, since I have 1.29 miles on top and the 5,280 feet is also on top in this calculation, that tells me that I need to multiply these two numbers together. When I multiply these two numbers together, I get 6,811.2. And over this year, I am going to use the anagram USS. I'm kind of a Star Trek nut, not just kind of, pretty major one. And that USS stands for units, sig figs, and scientific notation. Your answers must have the correct units, they must be in scientific notation, and they must have the correct number of sig figs. The easiest thing to do first is actually to do it in the opposite order. Get scientific notation first. So I'm going to get scientific notation. And by the way, I'm actually going to write this in green. Sometimes I'll mess up and put things in the wrong color. But you don't have to show the interim value. You're welcome to put these values that you get in between and you're working on, but you don't have to put them. You have to put the final answer, which I'll show you in a moment. So since I have this, the next thing that I need to do is to get this in scientific notation, move that decimal to the correct position, which is here. Since this number is greater than 1, it's going to be a positive exponent. So I have 6.8112. I moved the decimal 3 places. And since, again, it's a number greater than 1 to start with, I want that times 10 to the 3 to be positive. So there's my value in scientific notation. Now I need the correct number of sig figs. I look at my original values, and my original value, I have 1.29. That has 3 sig figs. Notice I did that in black. That also does not have to be on your paper. Counting numbers never count for sig figs. Counting numbers never count, okay? Numbers that are exact numbers do not count for sig figs. The 5,280 feet is a counting number. It's an exact number, okay? Therefore, it does not count for sig figs if it's in a conversion factor. The given over here, I don't care if it's a whole number or what it is, it always counts for sig figs. But our conversion factors, we have to decide, is it a counting number or is it an exact number? Or is it an exact number? Does it have infinite sig figs? Because if you think about this, 5,280.00000 feet is 1 mile. What this says is that this has infinite sig figs. If it has infinite sig figs, I'm going to draw a little infinite mark above here. Infinite sig figs means that's never going to be the smallest number of sig figs. So obviously the 3 sig figs from the 1.29 is going to be our smallest number of sig figs. So we draw our sig fig line. The beautiful part is that all scientific notation values are significant. We simply have to look at that last one, or that one right after the sig fig line, to decide if it needs to be rounded, and since it's a 1, it does not. So our answer becomes 6.81 times 10 to the third, and this is where we put our units in, and our units are what we circled before, feet, and that's our answer. Okay, and if you have questions, obviously you can talk with me, but you also can rewind this and watch parts of it again. So now let's look at one more example, and I would like for you to start it and just see how far you can get without me having to show you. So try that real quick. So hopefully when you look at this problem, you remember that you have to circle what it's asking for. It's asking us how many meters are in 2.5400 inches, and that 2.5400 inches is a piece of information that we were given. So what that tells us is that we need a conversion factor between meters and inches. And we found this conversion factor. You can look at your chart. We found this conversion factor when we were dealing with our conversion factors earlier in this set of notes. And we found out that in 1 meter, there are 39.37 inches. So that's our equivalency statement. We don't have to have it, but what we do have to have in the problem is that statement written as conversion factor. Now, I'm going to erase this previous answer if that's okay with you all, because it's kind of getting in my way for answering this next part of the problem. Because remember, in this position, if you write it in a different position other than right immediately after the word problem, you're going to lose points for putting it in the wrong place. I do not want it down here. It's going to interfere with your calculation. So always put it here. Now I want my equivalent statement, the fact that there's 1 meter over 39.37 inches and 39.37 inches over 1 meter. I want that conversion factor written as a ratio in brackets after that problem. So there's our startup. So now we can start our calculation. Remember, the calculation always starts with what we know, the only piece of information given us in the word problem. Please don't start this problem with 39.37 inches. That's not part of the word problem. That's the conversion factor. So 2.5400 inches is our starting point. Remember what we do with it. Whatever's underlined in the problem, we're going to underline here, put it over 1 just to show position, and put it in parentheses. That's always going to be our starting point. Whatever we underline in the word problem is going to start our calculation. So now that we have 2.5400 inches, I'm going to write my conversion skeleton. I know that's kind of a creepy sounding term, but that's what I've always called it. And I'm going to choose which conversion factor I want. So see if you can do that real quick on your own, remembering how we know which conversion factor to use. So hopefully you remembered that in order to reduce the units to 1, we need to have whatever the unit is we started with has to be on bottom in the conversion factor so that it will reduce to 1. They must be on opposite sides of the division line. So if that's true, then it looks like I'm going to need this first conversion factor right here because that's the one that has inches on the bottom. So that's the one that I'm going to put in. The 39.37 inches goes on bottom, the 1 meter goes on top. So there's the calculation. To double check that I've got it correct, remember we want to circle the unit we're left with. And when I circle meters, what do we compare it with? We compare it with what we circled in the word problem. And they should match. So you've got a couple of little double checks here to make sure that you set this calculation part of the problem up correctly. So now let's look at how this one is different from the previous problem. Notice that we always have our given on top, the first part of the problem. But look at where our non-zero number value is in this problem. It's on the bottom. The 39.37 is on the bottom here. What does that mean? That means that we need to divide these two values. We always multiply by what's on top and divide by what's on bottom. So when we plug this in our calculator, we're going to plug in 2.5400 if you wish. You could leave those off. They don't matter as far as the number value is concerned. But 2.54 divided by 39.37. And when we do that, we get the number value. I guess I should keep this red to keep my system going. And this in green because you don't have to show the interim value. I imagine everybody pretty much is going to want to at first until you get used to it. But here's our our interim number value. It's not USS, it's not unit, sig, figs, and scientific notation, but that is the correct numerical value. Now you're going to lose all your points for this even though it's correct if you don't represent it correctly. It's got to be USS. So the first thing, scientific notation. Let's get this in correct scientific notation. So we know the decimal needs to go here. It's a number less than 1, so you know that it's going to be something times 10 to the negative something. So moving that decimal, we ended up with 6.45161. And we had to move that decimal 2 places in order to get it in the correct position. So 6.45161 times 10 to the negative second. So now we've got it in scientific notation. Our next step is sig figs. So let's count up our sig figs in the problem. Remember, the given always counts. Even if the given was 2.5, or excuse me, 25, a whole number, it would still count for sig figs. Okay, always counts for sig figs. So 2.5400, the 2, the 5, and the 4 are automatically significant. Those last two zeros are significant also because there's a decimal showing. So 5 sig figs for this. Now, 39.37, is that a counting number? Would you count, if you were counting apples, would you ever end up with 39.37 apples? And the answer is no, that is not a counting number. Since it's not a counting number, it's a measurement value that does not have infinite sig figs. We have to use the sig figs in this one as well. Okay, there's a simple way of doing this that works 99% of the time. If there is a decimal in the conversion factor, it's probably almost, like I said, 99% of the time going to count. So all of these are non-zero values, so there's 4 sig figs here. If there's not a decimal showing like there was up here, that one, like I said, 99% of the time, you know it's an infinite value. So that's generally our way, a quick way of telling. So since I have 5 sig figs in this first value and only 4 in the next value, looks like our number of sig figs in our answer has to be 4 as well. So let's draw our sig fig line after 4 sig figs. So here's the sig fig line. And the next number after the sig fig line is a 6. So what does that mean? Yeah, it means we're going to need to round up. So the answer to this is going to be 6.452 times 10 to the negative second. And what's the last thing? Units. The circled unit was meters. That's what goes here. I may not have mentioned it last time, but if you don't box this answer, you're going to lose all your points. So make sure you, not all your points, I'm sorry, you're going to lose a point. So make sure you box your answer. And if you see all the stuff that's up there, you can see why we like you to box your answer so we can find it quickly. Make sure you do everything that's in blue or red on this problem.